Welcome to today's video presentation, VHDL Hardware Refactoring with Sigasi Studio. My name's David Clift. I'm an Applications Specialist at FirstEDA. So the first question is, what is hardware refactoring? Hardware refactoring, or more specifically VHDL refactoring, is a technology that helps digital hardware designers create better hardware in a shorter time. Designing, improving and reusing digital circuits traditionally involves typing, and lots of it. This is a time-consuming and error-prone activity that keeps engineers from thinking about what is really important, the hardware itself. HDL refactoring tools automate modifications to hardware code while the designer remains in full control. This way, the HDL designer can focus on the creative part while the refactoring tool does the dirty work. Hardware refactoring is a natural extension of software code refactoring, a well-established technology in the software engineering sphere used to improve code quality. The trend of applying refactoring techniques to hardware designs began with research from the University of Darmstadt and Synopsys, and has now resulted in Sigasi's patented pending VHDL refactoring tool. So that's the theory. Let's have a look at it in practice. First thing I would say is, if you're going to be using the refactoring tool, there's a small setting you can change that will make things a bit easier for you to see what's going on when you start off. So if I go to Windows, Preferences, Sigasi VHDL Refactoring, and remove this rename in editor without dialog if possible, and apply and close. So now we've got a bit of code and we want to refactor the signal. So for example, the reset port on this entity should actually be N reset because it's an active low reset and I want to comply with my coding guidelines. So what I'm going to do is right click on it and select refactor element rename, and it will pop up with this little dialog box. So this signal should be N_reset. Now at this point I can just click OK and it will go through and rename all the reset signals in this file and any places where else it's used in the design for this entity. But what I want to do is, if I click preview, I will get a diff so I can see where my change is going to be made. So here is the first one. Reset will become N reset, line 21 of the source code, and I can pick the other errors here. Here you can see if reset equals 1 becomes if N reset equals 1. Note that the comment wasn't touched because we're only changing signals. So we can carry on through and we can see the other places where it's changed. So here in the port map, it's changed it here. But no, if we look in the top section, we can see obviously this was the file we started off, vtim.vhd, but it's also changed tgen.vhd. So we've got a port change and a couple of port map changes further down. So now if I click OK, it will go away, change all the files and save those modifications.
Thank you for viewing this video. I hope you found it interesting and informative. If you require further information, please visit our website at www.firsteda.com. Thank you.